Welcome. In this video, you will learn how to create different types of loads and how to apply those loads to a mat foundation in STAAD Foundation Advanced. In addition, you will also learn how to create the load combinations that will be required for analysis and design. Please note that we are creating these loads in STAAD Foundation Advanced since we created this mat directly in the program. Therefore, no loads were transferred into the program from a superstructure model. When a superstructure model is imported, the support reactions from the columns are brought into STAAD Foundation Advanced during the import process and will be converted into the loads automatically. In this video, we will be creating two different loads. The first load will represent the material load, while the second load will represent the machinery. The material load will consider 20 kilonewtons per square meter or 30 kilonewtons per square meter, depending where you are on the mat foundation. The material load will also be assigned in the program as a dead load. The machinery load will be defined with 4 different values at 4 discrete points on the mat foundation. The machinery load will be assigned in the program as a live load. We will now turn our attention to the main application, where we will create and assign the loads to the mat. In the ribbon toolbar, select the Loading tab, where you can enter the loading specification and the load items. The loading specifications will be used to create new primary load cases and to generate or create load combinations using the primary load cases. There are a variety of load items that you can use to model the loading on the mat foundation. The first type of load that you can create and assign is a point load. When defining a point load, you can select either the contact area option or the point load option. The next type of load that you can create and assign is a line load. Finally, you can also create and assign an area load to the mat foundation. When modeling loads in STAAD Foundation Advanced, you will follow a 2-step procedure. First, you will create the load, and then you will assign the load to the mat foundation. Each load type has its own tool to assign the load. Each assignment option will require you to define the location on the mat where the load is acting. Before we assign loads to the mat foundation, let's take a look at the different types of loads that can be assigned in STAAD Foundation Advanced and the variables that you will need to define or create them. First, let's take a look at the point load option. Point loads can be defined in the program as a point force or a point moment. In addition, if you plan on assigning your point load with a contact area, you will need to enter the dimensions of the contact area and the orientation angle. Next, let's take a look at the area load options. Area loads can be defined in the program as a pressure along the global vertical direction. In addition, you can enter the vertices that define the load, or you can specify that the area load shall be applied over the entire mat or over a region within the mat. Now, let's go ahead and see how the loads are assigned to the mat foundation. If you assign the point loads through a needlepoint, the program will convert the force to a pressure and the moment equal and opposite forces at the corners of the contact area. If you assign an area load, the profile of the loaded area will become a controlled boundary for the finite element mesh of the mat foundation. The area load will be applied as a pressure on the loaded area. Now let's discuss the practicality of these types of loads. Point loads are primarily intended to be applied as a load on a beam, but it can also be applied to mats or regions. If the point load is applied to a contact area, it is intended to be applied as a pressure on the mat or region. Area loads are primarily intended to be applied when the source of the load is a pressure, such as the weight of the soil above the mat or region. Finally, let's discuss how punching shear checks are performed with each type of load. The punching shear checks will not be performed for point loads or area loads. Punching shear checks will, however, be performed on point loads that are applied to a contact area. Now, let's turn our attention back to the main application, where we will start the process of modeling the loads on the mat foundation. The first step in the loading workflow will be to create the primary load cases. To do that, select the Loading tab in the ribbon toolbar and click on the primary icon within the selection tools. Notice that the Create Load Case dialog is now available in the data area. In this dialog, enter the relevant parameters for your first load case. For our example, the first load case will represent dead load. The associated load parameters are not appropriate for a model that is created directly in STAAD Foundation Advanced. These specific fields are for models where the superstructure was brought in from an analysis program. When you are done entering the primary load case parameters, click on the Create button to complete the command. We will now repeat this process to create the live load primary load case. Our model now contains 2 load cases. We can now model the loads for each of these load cases that we defined. Let's start with the area load. To do that, select the Load tab in the ribbon toolbar and click on the Create Area Load icon. In the data area, specify the appropriate load case and the magnitude of the pressure load. For this example, I am creating a pressure load of 20 kilonewtons per meter squared. Notice that the pressure load is entered as a negative pressure, indicating that this is a downward acting force. When you are done entering all of the area load parameters, click on the Create button to complete this command. Notice that the area load has been added to the appropriate load case in the Project Explorer. If you need to create additional area loads, click on the Create Area Load icon again and follow the same workflow as the previous exercise. Let's go ahead and work on the point loads now, which will be acting on a contact area for this example. In the ribbon toolbar, select the Loading tab and then click on the Contact Area icon and the Contact Area Load option. In the data area, specify the appropriate load case and point load parameters. Notice the sign convention that is used to define the load magnitudes. As a reminder, a negative force is a downward acting load. Lastly, enter the contact area dimensions and orientation. You can also preview the load with respect to the orientation before you officially model the point load. In the main window, you can review the global axis orientation parameters that are entered correctly with respect to the orientation of the mat foundation. When you are done entering all of the point load parameters, including the contact area information, click on the Create button to complete the command. Notice that the point load has been added to the appropriate load case in the Project Explorer. At this point, additional loads can be modeled as required. For this example, notice that we created 4 point loads in the live load primary load case. Let's go ahead and review the loads that we created and where the loads will be imposed on the mat foundation. On this slide, I have identified where each load with the global coordinate values will be placed on the mat foundation in STAAD Foundation Advanced. We will now turn our attention back to the main application, where we'll start applying the loads that we previously created to the mat foundation. We will start with the first area load. In the ribbon toolbar, click on the Loading tab and then click on the Assign by Point icon within the Area Load tools. In the data area, select the load case and load item that you are working on. Then use your cursor to select the appropriate coordinates in the view window. We will now repeat this process for the next area load. Next, let's assign the point loads through the contact area option. To do that, select the Loading tab in the ribbon toolbar and click on the Assign Point Load icon. In the data area, select the load case and the load item that you are working on. Next, use your cursor to select the appropriate coordinates in the view window and then click on the Assign button. We will now repeat this process for the remaining point loads. Notice that the contact area for each point load can also be entered directly in this table in the data area using the X, Y, and Z reference point fields. This completes our workflow for assigning loads to the mat foundation directly in STAAD Foundation Advanced. To review and verify the assigned loading, highlight a particular load in the Project Explorer to see it in the view window. The last step in our workflow is to create the load combinations using the primary load cases that we defined. To do that, select the Loading tab in the ribbon toolbar and click on the Combination Specification icon. In the data area, enter the combination information, including the name of the combination, the type of combination, and the appropriate load cases and factors. When you are finished, click on the Create button to complete the command.